Thank you. Hi, everybody. My name is Andy Jiang. I'm a junior at Klein Oak High School based out of Houston, Texas. You might have noticed that I'm a bit younger than some of the other presenters, but I think it gives me a unique perspective on the problem of classroom attendance. So I joke that I'm a subject matter expert on the issue of attending class. This is my project Recog. I developed this under the supervision of Dr. Sun of California Polytechnic University. So as our name suggests, the problem my project tried to tackle was classroom attendance. Since the beginning of the COVID-19 pandemic, education largely shifted away from the physical sphere, and it transferred over to more virtual platforms. And this greatly simplified classroom attendance problems, as newly created programming scripts could easily just track the names of the students in a Zoom meeting. But with the recent return to in-person education, it became really rather clear that the problem of attendance within the context of a physical classroom hasn't yet been automated in a really effective manner. And this becomes a significant issue in larger classrooms as teachers are forced to allocate a lot of valuable time for the purpose of completing such a menial task. They can lose up to around 10 hours per school year, and that amount of time worth of instructional value is significant, and we hope to change that. So our solution was Recog classroom attendance. So to solve this issue, machine learning algorithms were sort of the first scape of solutions that we had considered. And within the context of our problem, we concluded that facial recognition would likely be the most feasible and effective approach that we could use. So Recog Classroom Attendance is a mobile application that applies real-time face recognition for the purpose of the above stated problem. And our vision for how this app was meant to be used goes as follows. So imagine that you're a student prepared to walk into English class. There'll be a mobile device set up next to the doorway, scanning the faces of those who pass by, matching them in real time with a directory of different pictures linked with corresponding student IDs. So as soon as the device's camera picks you up, you're marked present. And so as we apply our application to in-person classrooms, our results show that our solutions are immensely effective in both saving time and reducing error. So some of the external tools that we've used for this, for the development of this application are shown on the screen right over here. So Flutter is a cross-platform mobile app framework for developing mobile apps for the purposes of accessibility and reduced development time. And normally you'd need at least 2 different languages for release on both Android and iOS. But with Flutter, it's write once, run on any mobile device. So we use this just to make sure our app is as accessible as possible with the least amount of development time. We also use TensorFlow, which is an open source library for creating machine learning models. We use this to create our face detection model. We also utilized Amazon Recognition, which is an online AWS AI tool that offers advanced computer vision capabilities. They have advanced cutting-edge facial comparison models for our purposes. We also utilized Firebase, which is a Google hosting service for databases, and we use it for authentication and hosting our content. It's a secure and efficient backend for storing data, and so we're using this as our primary backend. So as we move forward, I just want to take you through a high-level overview of our app's workflow. And Recog is split primarily into 3 sections: the database or backend, the detection process, and the actual face recognition portion of the app. So our database is structured fairly simply. There are 2 groups: individuals and classes, or students and classes. And so students are essentially the individuals that we want to track the attendance of. We'll take some information from them, like a photo of their face, their student ID, their name, and we group those into classes, which are like essentially what they sound like, right? So we'll take a name from them, a description, and the time at which the attendance process should be taking place. And so we used Firebase for this, as we mentioned. So it allows for the fast and easy retrieval of information from the cloud. And so it creates a really efficient link to our backend. So here are a couple of screenshots from our app, with the first two displaying the contents of the database. Those are display screens for our app, and the second two being add screens for both categories. So you see here on the first one that it is a display list view for all our different classes, and with the second, a list view of all the different students in your directory. So moving on to the second, we have the detection process. We used a TensorFlow facial detection model, and it allows for really quick and efficient results. Our face detection process begins by opening up a real-time video feed from our device's camera view. And any human faces that get close to the device are detected, and a bounding box is drawn over them to isolate the face. After the bounding box is drawn, Recog provides a snapshot of the face, which is passed along to the next part of our workflow, which is the recognition part of it. As we mentioned before, the recognition model uses Amazon recognition, which is a really quick, advanced tool that matches faces instantly. So this is a basic flowchart of the recognition process. So the leftmost person icon signifies the face snapshot supplied by our previous detection model, which is fed to the Amazon recognition comparison model. It returns 2 bits of information: the person which the model suspects the face to belong to, given them the form of an ID, and a certainty metric, which shows how certain or sure the algorithm is of its conclusion. If the certainty metric is above a certain threshold, we redirect the user to a verification screen to ask whether or not this ID, being this ID and this like original face, we're asking the user to verify whether or not that's done. So I just want to take a quick little video demo to show you how the app is meant to function. All right, so that was the video demonstration. And so I just want to take you through a couple of experiments that we did with our app. And so in this, we tested our face detection model with a range of different light levels, ranging from around 250 to 1500 lux, which is a measurement unit of ambient light in environment. And so you see here that our app performs well overall, achieving a 98% accuracy rate over all light levels. And over standard classroom light conditions, which is around like 400 to 1000 lux, our model scored a 100% accuracy rate. For this, which was outdoors versus indoors, our model scored a 99% accuracy outdoors and a 100% accuracy indoors. And so this shows that even with additional stimulus and like random noise in the background of the camera view, like trees swaying in the wind, our model still performs adequately. So we tested here with in motion and still images. So when the individual is in motion, the photo becomes a little bit blurry and the photo loses a little bit of fidelity, but still our model performs adequately with a 95% accuracy rate with in motion pictures and then 100% with stills. So now we test a face recognition model, which scores a 93% accuracy rate over all light conditions and a 99% accuracy rate over standard light conditions. And so you see here, it's slightly more sensitive to changes in photo quality, and it scored slightly worse with these conditions. And so for the face recognition experiment with in motion versus stills, we see here that the recognition model lost a significant bit of accuracy as the photo of the individual got more blurry. But you see here that 84%, it scores at 84% for in motion pictures and a 100% for stills. And for the final experiment, which was face recognition for both outdoors and indoors, it scored a 94% accuracy outdoors and a 99% accuracy indoors. And so overall, our face recognition model scores a 92% accuracy rate over all the tested environmental conditions. And so this is like especially impressive given the fact that the environments that we are testing aren't normal, wouldn't normally be present for a standard classroom environment. And it shows how robust the model that we use is. So here we have a couple of future development targets for this project. So in terms of workflow, ideally we want our users to have as seamless of an experience as possible. And so right now they still do have to do some verification work. In the future, we hope to get rid of that entirely so that each student can simply walk by and be marked present without intervention on their part. In terms of the graphics user interface, there's some room for improvement in terms of the aesthetics of the app, and Recog can be made to be more stylistically appealing and efficient in terms of looks. In our backend, we can, in terms of our search functions, we can reduce lag times even further by optimizing the way we access our database. And our recognition model. Recog currently relies on the AWS recognition tool, but by creating our own customized algorithm, we could probably achieve even greater speed and accuracy for this project. Additionally, we want our users to have as much information as possible with this app. And so we want to provide more info by creating a log for each attendance process. And so each individual that's checked in would be marked with a timestamp and potentially other details. And so in conclusion, in this project, we proposed a novel approach to automating classroom attendance through a mobile app-based face recognition model. Overall, our experiments were able to verify the effectiveness of our application, and it resulted in pretty significantly accurate scores that showed satisfactory efficacy. And therefore, we concluded that Recog could become a suitable alternative to traditional classroom attendance methods. Additionally, this solution can be applied elsewhere, not just limited to the classroom setting. Workplaces, clubs, or even amusement parks could use this And as such, there's a great amount of utility in this app. All right. Thank you very much. And for some final remarks, I want to thank Dr. Sun for his supervision. I learned a lot over the course of developing this project. Excited to share with y'all and continue with the improving with this app. Does anybody have any questions, comments, concerns?